Okay. Today webinar is about fuzzy set qualitative comparative analysis, and I will try to, based on our time, try to go through this method and cover some part of this method. Before starting my talk and webinar about FS QCA, let me introduce a few papers and books related to methodology. This is a book that we published in 2022. Actually, we started to publish this book with Professor Fevzi Okumuz and Dr. Shiva Jahani in 2021, I think. And we planned to publish one book, but ended up to publish 3 books on methodology, research methodology, in hospitality and tourism, but of course it's not only for hospitality and tourism. Other social science and business field also can use these books. The first one actually is a contemporary research method that mainly we focus on some basic research method that can be applied, basic quantitative and qualitative that can be applied in tourism and hospitality, and also business and in wider actually discipline. This is the second book that we publish through this project, and this advanced research method in hospitality and tourism. And in this actually book you can find some chapter related to mixed method and some advanced method like neuromarketing, or using archival material, or online review, or text mining in this book. And the third one actually is a cutting edge research method in hospitality and tourism that again some advanced and cutting edge research method have been discussed in this book. One of the chapter in this book is our chapter for fuzzy set qualitative comparative analysis, that for this webinar also mainly this is one of the main source that I use for this webinar and FSQCA workshop. So all chapters in these 3 books come with some clear guideline, and most of them with some examples that you can follow any of this method that you want to apply. These are a few methodology papers that I published with my colleagues on different topics. One of this methodology paper that published in International Journal of Contemporary Hospitality Management is combined use of symmetric and asymmetric approach, that we try to provide a guideline to combine PLS-SEM and FSQCA. And also there are a few more chapters. Another one that published in IGCHM is about scale development. And here we try to provide a method that is useful for both reflective and composite scale. And we revise the current scale development procedures. Also, there are some articles on mediation analysis, moderation analysis, and this is my YouTube channel. So if you didn't subscribe yet, so you can subscribe in my YouTube
Allah
channel,
açıklığı.
and there are some
Bütün
videos.
öğrencilerin arkasında
Uh,
dediğimiz.
there are
Görüşürüz
some
canım. İyi yolculuklar.
videos related to different methods that maybe can be useful for you. This is the paper that I mentioned that we published in 2021. And in this paper, we discuss how a symmetrical approach like PLS-SEM can be combined with FSQCA, and we provided a guideline. And this is the chapter that I mentioned that in this chapter there is a guideline, step-by-step guideline to perform FSQCA, and also the application of software, FSQCA software, that you can refer to this uh, you can refer to this chapter and use for your FSQCA analysis. Here there are a few papers that we publish from 2021 by applying FSQCA, and you can see application of this method mostly in combination with structural equation modeling and PLS-SEM. Okay, let's go through the content of this webinar. I will try to explain a bit about history and definition of FSQCA, a few main steps of FSQCA that are membership and calibration, creating truth table, assessment of consistency and coverage, and necessary condition analysis. If you have time, talking a bit about XY plot and predictive power in FSQCA. First, a bit about history of FSQCA. Actually, FSQCA, the original method that FSQCA actually comes from, this method is the QCA. QCA is stand for Qualitative Comparative Analysis, and developed by Charles Raguin 1980s, and mainly actually apply in and came from political science and historical sociology for complex social and political condition, and work with the small sample size. So originally this method, qualitative comparative analysis, is a qualitative method, but of course for applying this method we need to quantify qualitative data, and then we can use this method for analyzing qualitative data for small sample. But this method later has been developed and applied for larger sample size and data set. And now you can see many papers that apply this method for quantitative data and large data set and sample. But the ability of this method, or the ability of QCA technique, is to analyze complex causation and complex relationship between social phenomena. This method is able to identify combination of factors that we called also recipe or configuration that lead to create outcome. So this method actually is able to identify, later we will discuss, sufficient combination of factors that can generate outcome or dependent variable. But the difference between this method and the current symmetrical approach that later we will discuss is, by this method that can be called a case-based method, we can identify different combination of factors that can lead to specific outcome and high level of outcome, and is different with the current symmetrical approach that only can identify one combination of factors. In tourism and hospitality, here there are now there are much more papers that apply this method. These are a few examples of application of FSQCA in tourism and hospitality, and of course other business discipline, information system, and other discipline also started to apply this method for quantitative data, different with the origin of this method that has been developed to apply for and analyze qualitative data. But what's the definition of this method? Here I have a very simple example to understand the main concept of this method, origin of this method, and definition of this method. For example, we are in a company that we have 10 employees in this company. And based on theory, we identify, I'm saying based on theory because like other social science studies, theory has a critical role to identify our research framework, and without theory actually we cannot develop some relationship, especially causal relationship in our research and study. So first, for developing research model and research framework, we need a strong theoretical ground. So let's say based on theory, we identified 3 factors that influence job satisfaction in this company. So we have these 3 factors that have been identified based on theory are salary, bonus, and promotion. So we know these 3 factors influence job satisfaction or can create job satisfaction in this company. But in a traditional symmetrical approach, we collect data from our employees, and after collecting data from employees, we can test the relationship between salary, bonus, promotion, and job satisfaction. And at the end, for example, salary will be significant. The effect of salary will be significant. Bonus won't be significant, and promotion also will be significant. And at the end, we conclude that salary and promotion have significant effect on job satisfaction, but bonus doesn't have any effect. So for actually the human resource development and human resource strategy in this company, managers think, okay, they have to focus on salary and promotion, and they don't need to focus on bonus because the impact of bonus, the effect of bonus on job satisfaction is not significant, right? So this is what we do in the symmetrical approach, because symmetrical approach is based on mean and average of, is a mean centric approach. So it's based on mean and average of salary, bonus, and promotion, for this case, of all employees. And we check the impact based on mean value and average of those actually answers and responses from our employee to job satisfaction. So we test this impact through this process. But when we apply QCA, QCA is a case-based approach. So in case number 1, we see salary. If salary is high and promotion is, there is a good regulation, rule and regulation for promotion, so staff will be satisfied. So if salary is high and there is good condition for promotion, he or she, first case, is satisfied. But for second case, if salary is high and bonus is high, that person will be satisfied. So it means for first case, bonus is not important. But for second case, bonus is important and promotion is not important. So we can see the difference between these two cases. Case number one and situation for case number one can be repeated for a few cases and employees or a group of employees in our company. And also situation with case number two can be repeated for a group of people. So at the end, if we combine this situation together and just test effect of salary, bonus and promotion on job satisfaction based on average that we get from different groups. So at the end, maybe the impact of one group is changed by the values and the answers that we have from other groups. So the final decision, the final result that we get is, okay, bonus doesn't have any significant impact on job satisfaction. But if we analyze different group of people, like case number one and case number two, we can see for a group of people similar to case one, salary and promotion are important, but for a group of people with similar to case two, bonus also is important criteria. So we need to consider this criteria and we need to consider bonus if we want to improve satisfaction of our employees. So here is actually the a description of this. If X and W can happen together, or X and Z can happen together for different group of people, and this combination of X and W or combination of X and Z can create and can lead to high level of outcome, we call this combination a sufficient combination that can result in high level of outcome. So this causal recipe, causal combination or configuration can be sufficient combination of factors to generate high level of outcome. And these combinations can be more than one combination of factors, different with the symmetrical approach. But if X is repeated in all sufficient configuration or causal combination that we have, we called X a necessary condition for generating outcome. Means if we come back to our example, if salary is repeated to for all employees and the answer of all employees and all of them different groups of people identify salary as an important factor, it means this condition is necessary to create job satisfaction. And if this factor is removed, we won't get high level of job satisfaction. So in this situation, X is necessary condition for generating outcome. For example, here for this company with the 10 employees, you can see for case number one, to be satisfied, once all factor, once high salary, good bonus, and good condition for promotion. But case number two only care about salary and bonus. And case number three, bonus and promotion, right? And case number four, only salary and bonus. So you can see for different cases in this company, you different combination of a salary, bonus, and promotion can lead to high level of job satisfaction. So here we can have 4 different situations. W, here you can see W. W is repeated. W is actually is part of all conditions that lead to high level of satisfaction. For case number 1, 2, 3, 4, 5, you can see W is part of factor that create high level of job satisfaction. Case number 6 is not satisfied, and for case number 8 and 9, 7, 8, and 9, also W is part of this process. So W is both sufficient and necessary, because W alone can create high level of job satisfaction, and also W is repeated in all combination of factors, so is sufficient and necessary condition to create outcome. X and W, combination of X and W and Z, X and W and Z, you can see these factors are sufficient. So because they can create high level of job satisfaction for a specific group of people. Here is one case, but this can represent a group of people that by combination of, for example, W and Z or X and W can have high level of job satisfaction. Case number 3, situation number 3, if we remove case number 5, employee number 5, W alone cannot create high level of job satisfaction, but W is part of all combination that we have. So W is necessary to create job satisfaction, but alone is not sufficient. Cannot create without other factor, cannot create job satisfaction, but is necessary component, is necessary factor that without this factor, job satisfaction cannot be achieved. And the X and Z is neither necessary nor sufficient, because cannot create high level of the satisfaction alone, and also they are not necessary condition for they are not repeated in all actually sufficient configuration or combination of factor that we have. So for each for our research model, these 4 situations can happen for different condition and factors that we have. Here are some example of studies that apply FSQCA. For example, here, so we I mentioned that is for complex situation. Here you can see we have 4 factors: social esteem, sustainability, social interaction, and economic benefit that influence intention to use P2P. So for this situation, we need to identify different combination of factors that can lead to intention to use, and this combination can be more than one combination of factors. So this study applied FSQCA to identify different combination that can be sufficient to generate intention to use. Is another study that you see airport services. There are so many factors that influence passenger satisfaction and revisit intention, and probably only one combination of these factors is not the only sufficient combination that can lead to satisfaction. And based on different group of customers or passengers, different group, different combination can generate satisfaction and revisit intention. So this study use FSQCA to identify different combinations. Sufficient combination can lead to satisfaction and revisit intention. This is our study that we use fsQCA to understand different dimension, a combination of different dimension of memorable experience. So including hedonism, novelty, local culture, refreshment, meaningfulness, knowledge, and involvement that influence satisfaction of tourists and the word of mouth and revisit intention. So again, here we realize that there is no only one combination of this dimension that can lead to satisfaction, and probably should be different combination of these dimension can lead to or can create high level of satisfaction and revisit intention of tourists. So we apply FSQCA. Okay, symmetrical versus asymmetrical approach. I explained that the reason that we apply a symmetrical approach and QCA or FSQCA because because of main difference with symmetrical approach. In symmetrical approach, here you can see regression equation for actually the study that involved X, W, and Z. When we apply symmetrical approach, we identify using different algorithm, we identify beta 1, beta 2, and beta 3. And based on these, we can say beta 1 is significant, beta coefficient 2 is significant or not, and 3 is significant or not. And based on uh, significance of a beta coefficient, we can conclude that what factor actually significant factor on a significant effect on y, and which one has no significant effect. So at the end, we identify only one possibility. Only we can identify, okay, X is significant or not, W and Z. So at the end, we have this regression line, right? So based on this regression line, we can identify, okay, X is a significant factor to create Y, W is not, and Z is significant factor. But using a symmetrical approach, we can identify different and various combination of these three factors that can create outcome, and is not only one possible sufficient situation, is multiple sufficient combination of factors that can create outcome. So but to perform QCA, we need to follow a few steps. QCA, the result of QCA is different with the result of symmetrical approach. And the algorithm and the process that we perform QCA and FSQCA also is different with the statistical analysis that we do for a symmetrical approach. For QCA, first we need to identify membership. Membership means we need to assign values between 0 to 1 to our data and rescale our data between 0 and 1. 1 means full membership of a data to a specific group, and 0 means full non-membership. So this is the first step that we need to do to perform QCA. But what's the meaning of this membership? Full non-membership means low level of a variable that we have. For example, satisfaction. If we measure satisfaction based on a few items and using 5-point Likert scale, we need to identify what values can be considered dissatisfaction and what values can be considered full satisfaction. So this should be identified based on theory. So first we need to actually go through a step and rescale our data based on the value that we need to identify from theory to see our data and our respondents answer actually identify what level of satisfaction they claim, high satisfaction or low satisfaction, zero satisfaction or full satisfaction. So based on this, in first step, we need to assign 0 and 1 for to our data that we collected from respondent for full non-membership and full membership. For this one, we have to calibrate our data. So assigning membership and calibration of data to rescale to 0 to 1 is first step for QCA analysis or FSQCA analysis. Here, FS come to picture, fuzzy set come to picture. We can calibrate our data and we can assign values to our data based on different methods. If we only assign two values to our data from certain values above certain values, for example, for satisfaction, we say, okay, we use 5-point Likert scale. So if respondent answer 1, 2, and 3, so we consider this no satisfaction. So we assign 0 to all respondents that answer 1, 2, 3 for satisfaction. Or if we have some items and we get average of items, if the average is less than 3, we say, okay, we assign 0 and we consider this no satisfaction. And for values above 3, so 3 and below is no satisfaction, and above 3 will be considered full satisfaction, right? If we rescale our data only based on two values, 0 and 1, so this is crisp QCA. This is crisp set QCA. So for crisp set QCA, only we have two values and we calibrate and rescale our data to only 0 and 1. But in reality, if we, especially for quantitative data, if only we calibrate our data, rescale our data to 0 to 1, we lose so many information, right? And the outcome won't be meaningful outcome. Because of this reason, for quantitative data, we move from this crisp set to multi-level and fuzzy set QCA. Also, some study, actually, some literature called multi-level and fuzzy set for column number 2, 3, 4. They call multi-level QCA, and only they call the last one continuous value fuzzy set. But some study also called this one 3-value fuzzy set, 5-value fuzzy set, 7, and the continuous fuzzy set. Okay, either method, either interpretation that you apply, fuzzy set, we assign multiple values to our data set between 0 and 1. So if we go for the highest level, that is continuous values, to we calibrate our data with continuous value and assign different values, continuous values to our data. So this one actually can be called fully fuzzy set QCA. So in this situation, 0 is called actually fully out and full non-membership. 0.5 is crossover, is neither in nor out. Between 0 and 0.5, we call out, actually is more out than in. So is more out of this group than in the group. And 0.5 to 1 can be more in than out. So also you can see other type of fuzzy set. If we consider fuzzy set, for example, for 5 values, 1 can be fully in, 0.75 can be more in than out, 0.5 crossover, and more out than in, 0.25, and 0 fully out. So this is the place that we convert QCA to FSQCA. So this depends on the type of calibration that we do and the values that actually we rescale our original data to those values. So this is actually in this place FSQCA come to picture. There are different methods for calibration, and so we have to identify to convert or to calibrate our original data to 0 to 1 in fuzzy set and continuous values between 0 to 1. We have to actually apply specific calibration method. And there are some calibration method that to see how our original data can be rescaled and calibrated to fuzzy values between 0 to 1. Two common methods, actually two common methods for calibration are using percentile approach. In percentile approach, we assign in percentile approach, we assign 5% percentile as non-membership or full non-membership, as 50% as crossover value, and 95% as full membership. Also, there are many studies that converted Likert scale to full membership and non-membership. So, for example, if you have 5-point Likert scale, they consider 5 or 4 as full membership value and assign values above 4 to 1 as full membership. They consider 1 and 2 as full non-membership and 3 as crossover. So values between this can be considered in or out. Or 5-point Likert scale, some study consider 7 for 7-point Likert scale. 7 as full membership, 1 as full non-membership, and 3 as crossover, and values between these actually have been converted to 4 as a crossover, and values between these are considered in or out values between 1 and 7. These are two common methods that have been applied in the literature to calibrate original data to fuzzy values. But in social science, especially, these common methods have some challenges and maybe some issues. This can be maybe some study for future research to compare different methods and see how accurate are those methods. But uh, uh, actually, the issue and challenges that we can consider for this type of calibration are when we apply, when we use average of, in social science, we most of time we have some latent variable that and construct that we measure by some items. If we want to apply this method, we need to get average of items to calculate score of each construct, right? And then based on the score of construct, use one of these method, common methods, percentile, or based on the value of Likert scale, convert to fuzzy values. So if we use average or some score to calculate score of construct or latent variable, so we actually ignore measurement error. You know, uh, when we apply structural equation, the reason to apply structural equation modeling is items to form or items to establish a construct have no same weightage or have no same contribution to create construct. So we apply SEM and calculate factor loading and some criteria to assess reliability and validity to consider this measurement error for each item to create construct. But when we apply sum score or average, we ignore this measurement error. Another issue that we actually can consider when we apply this common method is in when we have a research method, when we have a research model, we have nomonological relationship between variables, and maybe we have a few layers of relationship between variables. But when we apply this common method to calculate construct score and calibrate our data, also we ignore this nomonological relationship. So these are two challenges that we can count and consider for common methods for calibration. So because of this reason, we, in combination of PLS-SEM, we propose uh, another method, and we recommend to use latent variable score from PLS-SEM. PLS-SEM can create unique latent variable score, different with CBSEM. CBSEM, we don't have unique latent variable score, and but in PLS we have. So you can use latent variable score from PLS-SEM, that is standardized value, and then use this value as input of FS QCA. So we can calibrate this standardized value, and for calibration of the standardized value, we propose using -3, 0, and 3 for non-membership, crossover, and full membership. And the reason for proposing this is based on percentile approach, but very accurate, and actually, and this can cover almost all values that we have, because -3 is 0. For standardized values is 0.1% in percentile, not 5% or even 1%. And 3 cover actually 99.9% of all values that we have. So we propose this one for calibration using PLS-SEM latent variable score. And we think based on this approach, you can overcome these two issues that we have with common methods. But it doesn't mean that you don't use this method. In some study also I use these common methods, and still need to do some maybe some future study to compare different calibration methods for FSQCA and see how a result can be different. So this is first step for performing FSQCA. Second step is to create the truth table. Truth table, through truth table, actually, we identify all possible combination of factors. And then in next step that we will discuss, see which combination of factor is sufficient or necessary to create outcome. So before identifying which one is necessary, which one is sufficient or necessary, we have to identify all possible combination of factors. So through truth table, we can create all possible combination of factors. If, for example, we have three predictors, three independent variables, possible combination of three factor will be 2 to the power of 3. So will be 8 possible combination of all factors that can happen. Doesn't mean that all are necessary or sufficient, but all possible combination will be 8 combination that include all factors. So for example, here for x, w, and z, if we have three factors x, w, and z, you can see these are 8 possible combination of factors that can happen, right? And then based on some Boolean operations, actually the QCA and of course FSQCA, now you know the difference between QCA and FSQCA. When we use FSQCA means we use different actually calibration values for QCA. For FSQCA, actually we use Boolean algebra, not conventional algebra and statistic. So in Boolean algebra, we use a few actually operations to combine factors, and three main operations that we use is negation operation. Is negative, similar to negative, but the meaning is different with negative that we have in conventional algebra. Is logical and logical or. So using these three operations, we can create more combination of factors, right? So if we combine, before that, just see this example. For example, if the value of A is 0.17, so you remember when we calibrate, all values and all data are between 0 and 1, right? The value of A, factor A, is 0.17. The value of factor B is 0.33. So when we combine these two factors using logical and, we have to, the result of this equation and using logical and is minimum of these two values. So A and B, the value for A and B will be 0.17. And logical OR is maximum value of two condition and two factors. So if A again 0.17 and B is 0.33, A plus B will be 0.33. and negation will be 1 minus this value. So if A is 0.17, so negation won't be minus 0.17, right? So will be 1 minus 0.17 and the value will be 0.83. So this is the way that these operation actually work for a combination of factors and different configuration. And so originally we have 2 to the power of 2 to the power of k causal combination, but using or and logical or and we can create 3 to the power of k minus 1 different condition that is not necessarily included all factors. Can be only 2 factors or can be only 1 factor. So this is all possible combination of factor that can be created. And then we in next step we will see out of this 3 to the power of k minus 1 condition or configuration or combination of factors, which one is sufficient or necessary to create outcome, right? So this is next step. Is a second step is creating truth table. And third step is to calculate consistency and coverage of all combinations or configuration or combination of factors. So we use consistency and coverage as 2 main criteria to identify necessity or sufficiency of configurations. So we will see based on some threshold, we can identify based on the value of consistency and compared to threshold, we can say, okay, this configuration is sufficient to create outcome or is not, or is necessary or is not. The meaning of consistency. Consistency in a very simple word, especially with crisp set, but the definition is same as FSQCA. So you can see the formula for FSQCA. But to understand what's the meaning of consistency, we go with the simplest way and simple definition with crisp set that only we have 2 values. So the definition of consistency is proportion of cases with a specific combination of factors that generate high level of outcome. Means, for example, if you have 100 cases, right, total, but out of 100 cases, this specific combination of factors come from 20 cases. So answer of 20 cases reflect this specific combination of X, W, and Z. Out of these 20 cases, 70 of them answer high level of outcome. So means for 17 of these 20 cases, they identify high level of, or they actually are satisfied with their job. For example, they satisfied with this service. And only 3 cases are not satisfied. So consistency is proportion of cases that are satisfied or generate high level of outcome compared to all cases that identify this specific combination. So for this case, for this specific configuration, consistency is 17 divided to 20. So it's 0.85, right? And in fuzzy set, actually, this is the formula that we calculate consistency for fuzzy set. So consistency of configuration 1 is summation of minimum of consistent configuration, the value of configuration, and the value of outcome divided to summation of value of configuration. So based on this, we can calculate consistency. And consistency should be higher than 0.8, means more than 80% of cases with this specific configuration should generate or be satisfied with the outcome, right? Or identify high level of outcome that we want to achieve. So 0.8 means 80% of cases should be high level, it should identify high level of outcome. So this is threshold for consistency, to show a sufficient combination of factors. What's the meaning of coverage? Coverage is number of cases of a specific combination, specific configuration that actually create or generate high level of or answer high level of outcome divided to total number of high value of outcome. What does it mean? For example, if you have, for these cases, or a previous case, 17 of them out of 20 answer or identify high level of outcome, or they are highly satisfied, right? And out of 100 cases, for example, let's say 51 of them, 51 of all cases, of 100 cases are satisfied with different combination of predictors, right? So coverage for this specific combination is 17 divided to 51. 17 divided to 51 is 1/3 and is about 33% or 0.33, right? So the coverage for this specific combination will be 0.33. And for fuzzy, the coverage is calculated based on this formula, and the coverage should be higher than 0.2, means at least 20% of cases that led to high level of outcome come from this specific combination of factors. Some study actually propose other values. For example, some study propose 0.4 or 0.5 for coverage. So it's actually depend on the area of research. It's similar to R square. When we go to literature for R square, literature actually provide different values and different thresholds for R square. For example, if we are in some areas that we investigate some success factor of performance of company, so literature propose the value of 0.2 as the minimum value to accept actually as acceptable R square, and consider higher than, for example, 0.65 or 0.7 as high R square. But for some study, especially behavioral science, that we don't add all factors that create our dependent variable, and only we focus on certain number of factors or a few factors. So for those study, if you go to the literature say for behavioral science, R square higher than 0.2 can be considered high, and sometimes for this type of a study, R square 0.02 can be considered acceptable. So this is the similar to the value of coverage. So coverage and the threshold for coverage depends on your area of research, and this can vary actually for different area of research and discipline. But overall literature said less than 0.2 cannot be accepted, but some literature proposed to go for higher values, for example, 0.4 or 0.5. Here there are some, in this table, I try to calculate, to show how we calculate coverage and consistency, but of course you don't need to calculate because software will calculate for you. And here is just to show you what's the process for consistency and the coverage calculation. Okay, let me, for example, go through one example. For example, if you look at row number 2, 3, 4, 5, 6, row number 6, it's negation of X and W and Z. So this is our combination or configuration, combination of factor and configuration. Number of cases are 300. But 50 cases, actually, 50 cases answer this or identify this combination. Means these cases, this combination actually have been extracted or identified from 50 cases and 50 responses. And out of these 50, 45 of them also answer high level of outcome. So Y is high for 45 out of these 50. So consistency is 45 divided to 50. Total number of these, total number of cases with this specific configuration. So the value of consistency is 0.9. 45 divided to 50. And coverage, 45 are number of cases with this specific configuration that led to high level of outcome. So we have 45 high outcome. What's the total number of high outcome is 220. So 45 divided to 220. So is 0.204. So about 20% of these 220 cases come from this specific configuration and these 45 cases. So coverage is 0.2. So this is a sufficient configuration that coverage, consistency, and coverage are higher than threshold. Consistency is higher than 0.8 and coverage is higher than 0.2. So actually this is the only example to understand. Also you can see different other configuration, and here I try to calculate in a very simple way consistency and coverage. This is for sufficient actually the a configuration or combination of factors. So we need to calculate consistency and coverage, and based on the value of coverage and consistency, we can identify sufficient configurations. But what's necessary condition? Necessary condition actually is for specific condition that the value of consistency and coverage are higher than 0.9. Remember, at the beginning, I explained that if I show you if X or W or some factor is repeated in all different combination that we have, means this value is necessary to create, because this factor is necessary to create outcome, because this factor has been repeated in different combination and different configuration that we have, right? But always 100% cannot happen. And the threshold to accept a condition as a necessary condition, it's to be repeated in 90% of cases that create high level of outcome. So coverage should be higher than 90% or 0.9. But necessary condition analysis or necessity analysis in FSQCA is only can actually identify possibility of a factor to be necessary or not. So we call this necessity in kind. Means a factor can be, only a factor has two choices: can be necessary or cannot. But we have also NCA, that is necessary condition analysis, not in FSQCA. It has its own algorithm and software that we can calculate necessity in degree. So how much necessary is this factor to create outcome? So it's not necessity in kind. So because of this reason, we don't call necessity analysis in FSQCA as NCA. NCA is necessity in degree. And here in FSQCA, we calculate necessity in kind, and we call necessity analysis in FSQCA. I remember my first paper that I published using FSQCA, I think it was in 2019 or 2020. Before final publication of my paper, I think was current issues in tourism, I share in ResearchGate. And when I share in ResearchGate accepted version of paper, I received an email from John Doll, and he explained to me in that paper. Actually, I mentioned that okay, this is FSQCA analysis and this is NCA analysis, necessary condition analysis. He explained to me that what you did is necessity analysis in FSQCA, and we work for NCA to develop some algorithm and procedure for NCA for a long time, and we use different analysis technique for NCA, and we calculate the necessity in degree. So, and ask me to possibly change this to necessity condition in FSQCA. I did, and I didn't use NCA in any of my paper after that. And instead of this, I said in the paper I mentioned necessity analysis in FSQCA, because actually it's in kind, not in degree. But I'm not sure it's good to say this one, but But this one is actually necessary condition analysis is bivariate analysis. Only we can identify necessity of one condition or factor that can be necessary to create outcome, but not for configuration. Yeah, so we are working on some paper that show how actually necessity analysis can be done for configuration. Hopefully, we can get actually acceptance for this paper. Okay, XY plot. XY plot is another way to calculate necessary and consistency and coverage. XY plot, actually the one axis is X and another axis is Y. And based on the formula of consistency and coverage, if all cases are in upper left side, this part, yeah, oh, sorry, upper left side, if all cases in upper left side, our consistency will be close to 1. But if some cases come under diagonal here, means some cases x is our condition or configuration is higher than y if you refer to the formula of consistency. So the value of consistency will be lower than 1. So this is another way to calculate consistency and also coverage. And for example, for this case, so it seems all cases are high or actually above this diagonal, and all cases actually are in upper left side. So the consistency for this condition or configuration will be almost 1. But if we have some cases here in this side, this will actually reduce the value of consistency, and consistency will be lower than 1. This is another way to calculate the consistency and coverage for a specific condition and configuration. Okay. Last part that I try to cover is predictive power. It's possible to calculate predictive power of our model and our research model and relationship and actually solution or configuration, sufficient configuration that we can we identify. So predictive power means to identify these sufficient combination can predict our outcome. It means is not only explaining the relationship. If in the future we repeat this type of study, so we know these combination of factors, if we get high predictive power, it shows that those factors can create and can predict, or this combination can predict our actually outcome. So to calculate predictive power, if you are familiar with asymmetrical analysis, especially the PLS-SEM, PLS-SEM is a predictive oriented or prediction oriented approach, and we have some methods like PLS predict to calculate and identify predictive power of our model. In our paper also we discuss how these two methods, FS QCA and PLS-SEM, can help each other and can work together to actually show the predictive power of model, because we can calculate predictive power in these two models, and both are a prediction oriented approach. So to calculate predictive power in FS QCA, we need to split our data So randomly we can split our data to two subsets and or two subsamples, and run fsQCA by one subsample, for example subsample 1, and based on analysis of subsample 1, we can calculate sufficient configurations and combination of factors. So, for example, if we use subsample 1 and run analysis, we identify 4 configurations that are sufficient configuration to generate outcome. Then, to check predictive power, we use this 4 configurations, sufficient configurations from subsample 1 to and use XY plot to calculate consistency and coverage of these configuration using subsample 2, and see if those configuration based on data from subsample 2 also can be sufficient to generate outcome or not. If based on subsample 2, consistency and coverage of those configuration, 4 configuration from first phase, still coverage and consistency are higher than threshold, so it means these 4 configuration are sufficient configuration to generate outcome. These show predictive power of our model, and these show that these configurations actually have high predictive power and can predict outcome also in future studies, right? So this is the way that we can calculate predictive power using XY plot for FSQC. Different software actually can be used for FSQCA. There is package in Stata software, also in R. You can find the QCA3 package to perform CRISP and FSQCA and multivariate or multi-level QCA, and also the software developed by Ragin, fsQCA 4 now is available and is free, so you can download for Windows or Mac and use for your analysis, so you don't need to pay for this software. And these are actually some available software or packages to perform analysis. Here are some steps from our book chapter. So you can refer to our book chapter, and in book chapter we explain step by step how your data can be transferred to but first you need to calibrate your data. You need to rescale your data to actually 0 to 1. Software can do for you, but you have to decide what will be the values of full non-membership and full membership, and also what approach you use for calibration, and you need to identify that approach. So you want to use latent variable score, or you want to use a percentile approach, or sum score using, or average using a Likert scale. So when you prepare your data and identify your calibration method, then you need to go to software, and you can open your file. Your file should be CSV format, so you can open your file in FSQCA software, and then there are some function for calibration, so you can use those function. But in the function, you have to identify what's actually in your data, original data, what values should be assigned to zero as non-membership, crossover, and also full membership. So you have to decide before going to software. And then you need to, after actually opening your data, you need to calibrate. In actually in the chapter, we explain what the type of function you can use. You can use the calibrate function, and this is x is your variable that you want to calibrate, n1 is full membership, n2 is crossover, and n3 is full non-membership. So you have to assign, you have to identify these values in this function, and then software will calibrate your data between 0 to 1. Do actually fuzzy set calibration for you. And then step 3 is creating truth table and do analysis. Then software will give you actually the value of coverage and consistency for different configuration, and you can see which combination based on by comparing to 0.8 and 0.2 threshold, which combination is sufficient to create outcome. uh, Software actually give you three different solution: complex, intermediate, and parsimonious solutions. And so you have to decide which one to choose. Intermediate is actually suitable for and recommended for normal situation. But if your area is very sensitive area and you want to identify all possible sufficient combination, so your situation is very complex and sensitive, you can go with the complex output. But you need to have good understanding of theory to see which sufficient configuration can be suitable or should be actually considered. But in normal situation, intermediate is actually the recommended one. Okay, step 4, also you can use XY plot, especially if you want to check predictive validity or predictive power of configuration. As I explained, you can identify with subsample 1, and in subsample 2 you can calculate consistency and coverage and see those configuration identify in first phase also are sufficient in based on subsample 2 or not. And based on this, you can identify predictive power. This is actually the process that we propose in our paper for combination of PLS-SEM and FS QCA. If you want to use latent variable score from PLS-SEM, you can follow this procedure and guideline. So you need to assess your model using PLS-SEM, especially measurement model. Also, you can do hypothesis testing and assess predictive power using PLS predict, and then use the latent variable score as input for FSQCA. Calibrate data by considering -3, 0, and 3, 0, and -3 as full membership, crossover, and non-membership. And then create truth table, do analysis, compare with the coverage and consistency threshold. Also, you can do a necessity analysis to identify a necessary condition. And in the last step, you can do actually a predictive power analysis. So if you want to combine these two methods, these are some references. And You can follow me in Facebook, LinkedIn, and subscribe to YouTube channel. And yeah, hope you enjoy and learn something from this webinar. So I'm
Thank
happy
you.
to take some question.
Thank you so much, everyone participated, and special thank you to Professor Mustafa Resulimanish for valuable insights that you shared with us today. Please feel free if you have any questions. I know that there are some questions on the box also. Yeah.
Yeah.
Del, can you ask a question, Del? You ask about the CBSAM.
So which question? If you can
It
read
says, is
for
it
me.
possible to use the CBSAM to do this? The time that you explained about the CBSAM and fuzzy sets, I think,
Yeah, of course.
PLS-SEM.
Yeah, there are many studies that combine CBSEM and FSQCA, but if you decide to use CBSEM, you need to do separately. So use CBSEM for assessment of measurement model, and then use one of the common method, for example, sum score or average, and one of the approach that I explained for calibration to do FSQCA. You cannot use latent variable score from CBSEM because CBSEM cannot create a unique value, unique latent variable score. Create some latent variable score, but in each time you analyze, you can get different value because in CBSEM we have indeterminacy issue. So there is no unique latent variable score or determinant value latent variable score. So you cannot use latent variable score from CBSEM, but you can use separately and report the result, especially for measurement model and FSQC.
Thank you so much. There's one other questions there. Is it moving away from Likert scale data for calibrations? If the data is collected via semi-structured interview, what could be good or recommended to calibrations approach? I'm thinking of relatively smaller sample size here, for example, number 25.
If you have qualitative data from semi-structured interview, first you need to quantify your data. I cannot give you any advice on this, and any approach for quantifying data is based on your area of research. So you need to see how your result of qualitative data and semi-structure or unstructured interview can be converted to values. For example, you have some teams or codes, you can add some value for different teams, or codes under each team can have some values. It depends. And then after quantifying your data, you can decide what values in your data, quantified qualitative data, can be considered full membership, what values can be non-membership or between crossover value. So you can use qualitative data, but you need to have strong knowledge to quantify your qualitative data.
Thank you. Yes, Leah. Sorry.
Yeah, good morning from me too. Thank you for the presentation. This is something that I was looking forward to attend, because I
Hopefully
heard
you
about
got
this
some good
method.
point.
Yeah, I know Nikos Papaski is using it a lot, so I know the reasoning behind it. The only question that I have is, yeah, I understand how we can quantify the qualitative data. I've done it before, but when I submitted the paper, there were many questions or criticism. There was a lot of criticism from the reviewers who could not understand why this was done. And I wanted to ask if you have any advice on how to justify this. Is there any source that we can use to justify that we did that in order to identify outcomes or predictions or?
Yeah. I haven't used for qualitative data yet, but it depends on my understanding and maybe my answer to those reviewers or some advice to you. It depends on your research question. If your study, your research question is something very inductive approach, and from scratch you want to develop something, so might not be suitable to use this type of method, because this type of method is somehow similar to because you use numerical data, and you transfer your data to numbers, so you need to have some structure and theory to support this one. If your study is very pure inductive study, probably is
That is,
not recommended to use this method. But if your study is, because in qualitative study also, in thematic analysis, we can apply deductive thematic analysis. So we can have some predetermined code for thematic analysis. If we have this type of study that can support from literature, and we can have a strong support from theory, maybe justification is much easier compared to pure inductive research.
just one more thing here, and I will leave you. If you have structured interviews where you have some elements that they have a Likert scale, then why
Yeah,
not do what you suggest?
you can if as I mentioned, even if you have if you apply deductive thematic analysis, so you don't have a structured interview, but you have some predetermined code, so it's good, and it's easier to justify application of this method, because you can easily you can quantify your data and use this method. But if it's pure inductive, so it's difficult.
Okay, thank you so much. Thank you.
My pleasure.
Thank you so much. There's another question, sorry. They said, thank you for a great presentation. It's inside. Please, in more practical terms, could you help to explain how to divide the data into subsample 1 and subsample 2 to plot the XY plot?
You can use the different methods. For example, in Excel, we can apply random approach to randomly divide our data to two groups. I know Excel, but I know also there are different methods or different even software to split your data randomly to different groups. So you can search and find different methods for splitting data. One of them I know is in Excel. It's possible, but it's not only one. I think there are a few different software and approaches to split your data.
Thank you. Is there any question? Soranjita, I think you had a question before.
I did. I mean, I'm quite new to the use of PLS-SEM. I've only done one bit of work on it. And I just wondered, is it worth going further into the FSQCA sort of methodology for publication? I mean, where is it in terms of, is it a necessary step to take forward for publication? And this is in change management, so not necessarily in hospitality, but I just wondered what your thoughts were on that.
It's not necessary, but actually there is a trend now that we apply multi-methods to analyze our data to
Sure.
get actually richer insight. And definitely using different methods to analyze data and get more insight can help and can increase your chance for publication, especially when you go for uh, top tier journal. But
Mm,
any method that we apply, we have to consider two very important things. First, look at your research question,
Hmm.
and really you need this method to answer your research question or not.
Mhm.
And
Yes.
the second one, any method that you apply, multi-method or one single method, you need to follow a robust procedure for each method. So look at the recent publication and recent literature and to see what's advancement in this method and how you should report the result. And so follow a robust process for
Yeah.
applying method and reporting it.
Thank you, Professor. It was a very insightful talk. Thank you so much for
My
that.
pleasure.
thank you so much. Any other question? Thank you so much, Professor, for accepting our invitations. And again, thank you for valuable insights you shared with us today. I hope have a chance to have another times to see you face to face.
Hopefully, yeah.
Yeah,
Thanks
that
for
would be
inviting me
great.
and having me today, and hope our participant actually enjoy and get some tips and insight for application of this method. Thank you.
I'm sure everyone they enjoy. Thank you so much again for your time. Thank you.
Thank you. Bye. Have a good day.
Thank you. Bye bye. Bye bye.